We will now look at how to graph a frequency distribution table using histograms. On the x-axis, we will have all the units being measured, and on the y-axis, we will have all the frequencies. The bars can be centered around the class midpoints or the class boundaries. There is no set standard. Let's take this frequency distribution table and create a histogram from it. I'm going to use class midpoints as our reference value. This also means that the class width is the distance between any two consecutive midpoints. We will build each bar up to its matching frequency. And remember, I could have used the class boundaries as my reference value as well. Another way to display information on a frequency distribution is to use a relative frequency distribution. When they say relative, they mean the frequency relative to the whole. The total frequency here is 50. Since the frequency of our first class is 11, 11 divided by 50 would be 22%. Similarly, for class 2, which has a frequency of 24, 24 divided by 50 is 48%. Notice how the shape of the histogram does not change, only the values on the y-axis change. Another way we can display information on a frequency distribution is with a cumulative frequency distribution. Cumulative frequency means the sum of all frequencies up to some instance. The total frequency up to my first class is 11. The total frequency, or the cumulative frequency, up to my second class is 35. The cumulative frequency up to my third class is 45, and so on and so forth. Notice how if we were to plot this on a histogram, the bars will be increasing from left to right, and they will always end when the total frequency is met. There are common reoccurring shapes in histograms. The first is the uniform distribution. This is where all the bars are the same or just about the same height. When we start our probability unit, this will be the first distribution we will review, and we would be considered lucky if our data fell into this pattern, since it's easy to do computations on. The second and third are skewed distributions, where one is left skewed and the other is right skewed. In my opinion, the definition can be a little bit confusing, so I use the hand trick. If the distribution looks like your left hand, we call it left skewed, and if it looks like your right hand, we call it right skewed. Lastly, we have the distribution from the heavens, the normal distribution. This is the most important distribution, and it has so much utility. We will discuss why this is so important in later videos, but for now, just note that a normal distribution peaks in the center and withers at its sides. You should always look for questionable data. The first thing you should watch out for is if the sample size is too small relative to the population. For example, if my population is the set of all chocolate bars in a chocolate factory, and I only take 5 chocolate bars from my sample, then my sample most likely will not represent the general population. We will talk later in this class what it means to be a sufficient sample size. Another thing you should watch out for is for clues that our sample was taken from 2 different populations. We can see this on a histogram if there is a gap between our bars and there are 2 different peaks. Lastly, look at the values of the data. If they all end in 0s or 5s, they most likely weren't measured and were probably rounded.